Question 14 of the May 2018 AS Paper 1, Edexcel. So we've got a circle question here. We've been given an equation of a circle, but this equation is not very user-friendly. We want to change that so that we can read off the coordinates of the centre and the radius. Okay, so the general equation of a circle looks like this. A couple of brackets squared equal to the radius squared. And the brackets, the first one has x in it, and then it'll be plus or minus some number. It's normally written as minus a. Okay, and then the next one will have y in it, and then again plus or minus some number, but we normally write it like this so that we can say that the centre is a comma b. Okay, and then the radius of course is r. Okay, so we need to get it in this form. So that should look familiar to you from GCSE. That looks like when you've changed a quadratic into brackets squared, it's completing the square. So that's exactly what we're going to do in part A. We're going to complete the square. So if we look at the x's, we've got an x squared and we've got minus 6x. Okay, and the method for completing the square is that you put half the coefficient of x into the bracket. Okay, and then you must subtract off that number squared. Okay, so that's the process for doing the x's. Now we do the process for the y's, exactly the same, but we've got plus 10y. So half the coefficient of y is 5. Okay, and again exactly the same, we subtract off the 5 squared, and then I mustn't forget the rest of this. There's a plus 9 and an equals 0 on the end, so we just get that copied. Okay, now that last step's very simple. You just collect all your numbers together. Okay, so I'm going to write the two squared brackets first. So I've got a minus 9 here, minus 25, so that's minus 34, and then plus 9 is minus 25. And then of course in the format that we want it, we don't want this minus 25 here. We want to take that over the other side so that it becomes, well, it's going to become equal to 25. So I'm just going to save myself a line of working out there, or a line of writing. Okay, so once we've got it in this form, we can read off, literally just read off the centre of the circle. So the x-coordinate is 3. Notice it's not minus 3, it's 3, because the formula is x minus a. Okay, so then when you've got y plus 5, that must mean the y-coordinate of the centre of the circle is negative 5. So this is the centre, and the radius, well, the radius isn't 25 because this is r squared, so it's the square root of 25, which of course is 5. So that's the final answer to part A. So part B, it says the line with equation y equals kx, where k is a constant, cuts C at two distinct points. So C is just a circle that we found in part A, and the line y equals kx is just a straight line. Okay, so let's just have a think about the different ways we could draw a circle and a line. So it misses the circle completely, okay, or it could do this. If the line is a tangent to the circle, it means it cuts, or you can say that it cuts the circle at one point. Okay, now clearly this question says that it cuts in two places, so our picture is going to look more like this. Okay, and if we were going to try and find those points, then what we would do is, I mean, this applies to any lines. It's nothing special about straight lines and circles, but if you want to find a point of intersection of any two lines, then you solve simultaneous equations. Okay, so we're going to get stuck into the algebra. We've got y equals kx, and then we've got this equation up here, or we could use our version here, because this is just a rearranged version of what we had. Okay, so part B, okay, I'm going to substitute y equals kx into this form here. Okay, so if I'm substituting everything else, I just copy. So I've got x minus 3 squared, okay, plus. So I'm going to change the y into kx. Okay, and the point of this is that you can see that the equation has only got x in it now. The letter k is just a number. Okay, so the letter k is just a number, so you would treat this as a piece of algebra that has only got x in it, and you would attempt to solve it. Okay, now the problem with this form is that you're going to have to expand the brackets anyway. Okay, so it may well have been better to have actually put y equals kx into this equation here. Okay, and let's do that. So let's not use this version. Okay, let's go for the other one. So we've got x squared plus y squared. Well, we just substitute everywhere we see y, we change it to kx. Okay, and then you can see that this is kind of in an expanded form already. Okay, so plus 10y, we change the y to kx, and we've got plus 9 equals 0. So either way is fine, but it's probably easier just to use the original equation with this one. So just expanded this bracket here, everything else has been copied down. Okay, so we want to look at how many x squareds we've got. Okay, so if you look at the x squareds, we've got 1 here plus k squared. Okay, so the best way to write that is 1 plus k squared in brackets with our x squared. You could just think of it as factorising the x squared out. Okay, if we do the same with the x's, the best thing to do is always put a plus sign down, open a bracket up, put an x down, and then just copy in what you've got. So I'm going to copy in a minus 6 and a plus 10k. Okay, could put it around the other way. I'm going to keep it in that same order. Okay, and then we've just got plus 9 equals 0. Now the reason that we need to write it like that is because, you know, it is a quadratic equation. We need to write it as a quadratic. Okay, so we get to our quadratic here, and you know, normally you'd look at this and think, oh, how are we going to solve this? It's, you know, it's still got k in it. We wouldn't really be able to solve it. We'd be able to get a range of values of k. But the easiest thing to do here is that the information that we've been given is that this straight line cuts the circle at 2 distinct points. So that gives us some information about the discriminant. Okay, so the discriminant is the portion of the quadratic formula that is inside the square root, b squared minus 4ac. Okay, and the information that we're being given is that if it cuts in 2 places, well, it means that we can square root that number, which means it must be a positive number. It must be bigger than 0. If it cut at just 1 point, a tangent, it would be equal to 0, and if it didn't cut at all, it would be less than 0. Okay, so we're just going to go ahead and plug our values of a, b and c into this discriminant. So b is this coefficient of x, so don't overcomplicate it, just copy it with a squared, and then it's minus 4 times a. Well, a is this coefficient of x squared, which is 1 plus k squared, and c is 9. Now, always try and put in the greater than 0. You really need that throughout the rest of the question. Just keep copying it down. You need to expand this bracket. It's probably easier if you write it as 10k minus 6 and expand it. Okay, but minus 6 squared is 36. You're going to get minus 6 times 10k twice. So you're going to get minus 60k twice. So that's minus 120k. And then you're going to get 10k times itself. So that's 100k squared. And then the easiest way to do the last bit is collect the 4 and the 9 together. So that's 36. So I've got minus 36 multiplied by this bracket. So minus 36 times 1 is minus 36. And minus 36 times positive k squared is negative 36k squared. Okay, so we need to collect our k squareds together first. So that's this one and this one done. We've got a 36 minus 36. That makes it a little bit easier. That's the numbers have disappeared, and then we just copy down this number here. Now we've got quite big numbers there. We can divide this down. It looks like 8 is going to be our biggest factor there. So if we divide both down by 8, just makes the numbers a little bit nicer. And then factorise the left hand side. And you've got to be thinking quadratic inequalities here. Probably the best thing to do is a little sketch. And don't worry about what letter you're using really when you're doing this. You can think of this as a k-axis. Okay, so it would cut at 0. And it would cut at, well, it will be 8k minus 15 equal to 0. So that would be k equals 15 over 8. So I'll put 15 over 8 here and draw a quadratic in. And we're looking at when it's greater than 0. So that's actually going to be this bit here and this bit here. So it's going to be k is less than 0 and k is greater than 15/8. So this is our range of values for k. It's always worth checking back on the question to see whether there's any limitations on what k can be. So if we go back to the original question, okay, it does just say that k is a constant. It doesn't give us any restrictions on that, so this is our final answer. K is less than 0, k is greater than 15/8.